What's up, everybody? Welcome to the debut of the Joe and Friends show. So this is Joe Reis. This is a chance for me to talk to some of the great minds in the data industry, as well as talk about what they're up to, the cool products they're working on, the technologies they're working on, and so forth. This is a bit different than other shows that I've done in the past, which is more technology and vendor agnostic. I feel that there are a lot of cool people in the data space doing some awesome things. So joining me today is Brian Olsen from Starburst Data and Trino.
What's up? How's it going, everybody?
What's up? How are you?
Hey, look at that dog back there.
Hi, girl. Time to leave.
Nice. So thanks for the intro there, Joe. Really cool to be the first guest on the show, Joe and Friends. I was really hoping for like kind of a Saved by the Bell intro coming on there and with that 80s backdrop, but still. So my name is Brian Olsen. I'm a developer advocate over on the Trino project. And also I work full-time at Starburst. A lot of times the Starburst data is actually kind of a handle thing, but you can call it Starburst, but in conversation, maybe the data will help you make sure that people know you're not talking about candy. We'll dive. I guess we'll dive a little bit into what Trino is. I'm not going to try to jump ahead too far. If you have any specific questions on it, but yeah, let's. Really excited for the show today. Thanks for inviting me.
Yeah, that's awesome. Yeah, thanks for. Yeah, I mean, we've done quite a few events with Starburst in the past at my meetups, and I've dorked around with Presto on and off for quite a few years now. So it's cool to see that there's some traction, and it's cool to see that there's a new name too.
Yeah.
Which is Trino. I mean, for people who don't know what Trino is, can you talk about that?
Yeah. So for anybody that's kind of like in the data space and data engineering space, you may have heard of a project called Presto. So basically, I'll give a quick background that there was one project called Presto that was created in 2012 by Martin Traverso, Dane Sundstrom, and David Phillips. And so they created that at Facebook. And back in 2012, 2018, there was a split in the community, kind of tangential to go about the details there, but oh, sure. So there was, a bit of your kind of typical open source drama, right? Facebook kind of wanted to have a little more tighter control over the project. Ultimately, that didn't jive well with the open source community as well as Martin, Dane, and David. So they ultimately split off, made a separate fork. They also called it Presto for like 2 years after that fork happened. And so that was called by Presto SQL. They used the kind of internet handles again to kind of distinguish between the two projects also called Presto. So there was a whole lot of confusion for like 2 years after the split. Presto DB was the kind of one that was still like the original one owned by Facebook. And then the split was called Presto SQL. A lot of community moved over. There's a bit of a rift there, a lot of confusion. But I think a lot of that got cleared up when the rename was instated. So Presto DB got donated at some point to Linux Foundation. They imposed a kind of trademark on the name Presto. And so we were kind of pushed into Martin, Dane, and David in particular were pushed into, making sure the name got changed and we weren't using Presto anymore, otherwise violating a trademark. So a little bit of drama there, but, got past that. And I think now being the name Trino, it just really helps kind of clear things up and distinguishes the two projects. And despite some initial efforts kind of going on after the initial split, it doesn't seem, a lot of people have asked, are these two getting back together at some point, or, is there going to be a reunited tour? And unfortunately, I am telling you today that, it doesn't seem like that's going to be the trajectory. Projects are going in two different directions, and ultimately, we're really excited to see where Trino is going, and that's what we'll probably focus on for today. So,
juicy tidbits. I had no idea about the insider drama there. It's like the breakup of a popular band or something. So
yeah, right. So if you want to read more about that, it's on Trino.io. Yeah, just go to Trino.io, and there's like a little blog that kind of gets into some of the details there. It's literally like a top banner thing we have there just to kind of clarify. It's like there's a lot of people in their community that are still like, yeah, presto, 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 and then we're like, oh yeah, but it's also Trino, and like we're doing this thing and primarily focusing on like a lot of the more open source side versus big tech company development. So let's get into actually, though, for those that haven't heard about Presto or Trino, let's talk about what that is. And I think that's the more interesting conversation. So, Trino was ultimately created as kind of this solution to, I don't know if anybody here, that listens to your show has ever worked on Hive. I'll assume that either you have set up a Hive cluster and you did a whole bunch of these very tediously slow MapReduce things, and it was super like constantly dealing with out of memory issues or just pipelines failing constantly. So that's kind of the data engineer point perspective. I know you also have a lot of like data consumer kind of like analysts, business analysts, and data scientists that listen to your show as well. So for those of you who are on that side, you were just like, why am I I need to run this one simple query just to see, how these two tables join together. And like, it takes, 7 hours or 8 hours for this thing to return. And it's like, scanning like, I don't know, 1 terabyte of data. So I like, it's like, I have like a million filters on this thing. What's it doing? And so you just go get a coffee. I think the anecdote back in the day was kind of, and maybe more of an aphorism now, is like every analyst that was working on Hive was like saying it'd be a good day if they could get 6 queries run. So this was kind of the issue that Martin, Dane, and David kind of came into at Facebook. They were like kind of dealing with a 300 petabyte scale data warehouse, all running on Hive, and they had these issues like analysts and data scientists were just not being effective. So initially, Trino was posed out there as like, hey, let's just basically replace a lot of the runtime that's going on here. I mean, it's this MapReduce kind of Hadoop runtime that is getting translated from this, kind of pseudo SQL language, which is just the HiveQL language that somewhat follows SQL, but not totally. And the other kind of weird part about Hive too was that, you have like different Frankenstein hives all over the place, whether you're with the Cloudera Hive or whether you're the Hortonworks Hive or whether...
Oh, I remember this.
Ooh, yeah.
Frankenhive. Yeah.
Frankenhive. Yeah. And it's like, you're just, you don't know which one you're going to run into to any new job you go to. You're like, which Hive are you running? And, that would just dictate all the different rules that you had to deal with. So it was just a lot of mess to deal with that. And so what Trino aimed to do is like, let's just replace that whole runtime layer first. Like, let's get rid of all the MapReduce, really like focused on fault tolerance and all this other, like just trying to make things to disk all the time. And let's just like tone that back a bit. And let's like think about what we can do. Like, why don't we make something that's much more scalable? So what they did is they made an Mpp architecture style where Mpp is massively parallel. And basically you're trying to focus on any way that you can run things in parallel, do that. So, think about like a kind of a hash bucketing algorithm where I get all this data, I'm trying to spit it out into like across nodes. And then once you're even at the node level, you're spitting it out across different threads. So you're trying to take parallel to the max. Other kind of rigorous engineering bits that were applied to this was like, like how do we, maybe like custom write JVM code that will be able to compile and run a lot more efficiently for us every single query we write. And that's done internally and a lot of times as well. So like every query that you write now, it's like custom compiled JVM code that gets run on these things. So there's a lot of different areas where they started to try to apply just smart engineering practice. And one of the things that they came from was like, they were using products that were enterprise only, kind of like things like Netezza. And they were like, we need to have something that's like Netezza, where you can just like, you install this box here, you basically just like plug everything in and then it just works. So this was like all of the kind of design principles that came in here. And what was produced was ultimately this this replacement for the Hive engine that ultimately still worked with your Hive metadata. You still have this Hive meta store that sits next to Trino, and ultimately stores data in HDFS. And later on, that ended up becoming S3 stores as we started moving towards cloud. So that was the primary fundamental use case, was let's replace Hive. Let's make this kind of query engine that sits on top of data lakes, that runs super fast, that runs everything in parallel, and doesn't have to do all these constant writes to disk for this maybe unnecessary fault tolerance if you're running just this interactive ad hoc analysis. So I'll stop there and let's see if there's a lot to take in and process. I don't know if we have any questions that come in, or if you wanted to.
I don't see any yet, but for the audience out there, thanks for tuning in. If you have any questions about Trino, Starburst, data mesh, data virtualization, anything that doesn't relate to these as well, Brian will be happy to answer them.
Sure. Yeah.
So you kind of walk through the history of it and why it came about. What are some use cases that you're seeing out there in the wild?
Yeah. So an interesting new development that happened just shortly after, while they were using this kind of Hive replacement at Facebook, queries were getting sped up. That's great, right? A new use case that started coming out, though, they were doing a lot of this A/B testing, and they used different systems to on the back end there. I might not totally get this exact story right of how this unfolded, but I know there were basically other use cases and drivers that started coming up around Trino, and they're like, hey, what if we use this system? And what if we use this other, like MySQL or I think the other one was just MySQL Postgres. Those were the kind of two initial ones that were starting to get asked simultaneously. From the beginning, Martin, Dane, and David made Trino open source. And one of the challenges with having the Trino talk to the open source Hive was they had two versions essentially. They had an internal Hive version that was Frankenhive that Facebook maintained, and this was nothing that you would see out in the wild. This was just Facebook's own Hive internal Hive version, and so they had to basically make a Trino that would talk to that Hive, and they also had to make a Trino that would talk to open source Hive in order for this to be open source. So there started to be this kind of use case where, hey, we need to talk to MySQL, we need to talk to Postgres, we also need to talk to these two versions of Hive. So what they started to do is they're like, well, what if we just made this layer, this generic kind of SPI layer, which is the service protocol interface that ultimately allows you to connect and talk to the kind of inner workings, like the query optimizer, all of the analyzer, all those different pieces that ultimately are kind of the core engine. Let's make an interface that sits between the core of what Trino is to talk to these different sources. And so we have different sources the two versions of Hive. We have now MySQL and they have Postgres. And one of these really interesting use cases that came up from that was this kind of query federation. Now I can actually talk to a MySQL. I can talk to Hive, all from the same place. And further, what's more interesting is now that I'm having this centralized query engine that sits up here, it does all of its, it has its own nodes sitting up in memory. It does all that slicing and dicing itself. I can now push some queries down to these lower levels, let that bring the data up to me, and then I can further, kind of join the data. So let's say I have a table in MySQL that I want to ad hoc join with something that in my data lake. Then I can do that. I can just, run a join across those two tables. So that's one of the use cases that really wasn't the intention of Trino whenever it was created, but just kind of unfolded as kind of those natural ones. And then the other, one was the one I kind of talked about. If you're sitting in Hive hell right now, listening to this, and you are like, man, this stuff runs so slow. You are the initial target use case of you have a data lake where Hive's running on top of it, or you have maybe another newer version of that, which is Impala or something like that. And things are just super, super slow for you. Or, maybe you're doing some sort of Spark SQL thing. All of these engines that run on currently, nothing runs as fast as Trino. And so, and I say that we have, data to back that up. And so, so really what it comes down to is there are some things that we give up, like fault tolerance and pieces like that we're also looking into, thinking about how do we add those back in. But the initial goal was not about, let's do what everybody else has done up to this point and try to, reallocate on that. No, let's try to hash on, how do we make these ad hoc queries across multiple data sources super fast? And that's where Trino came in. And so it becomes this like query engine that ultimately replaces your Hive hell, but then can become and grow into so much more. It can be, it can start to extend out to reach out to these other databases where, if you want to connect, let's say you have a real-time use case and you want to talk to Pinot. Pinot is another analytics engine, very similar to Trino, right? But it's like its primary goal is to actually query this data in real time. And so if you have historical data sitting in your data lake, and you want to like join that with real-time data coming in, then you can ultimately run these cross joins between real-time data and your data at rest that's kind of been, historical data. And this is really super useful for like machine learning applications. This is useful for like, if you really need to, some quick ETL stuff, if you're trying to quickly do some sort of test, A/B testing. So a lot of different use cases now from those two use cases that I covered that you can start to dream up now that you can, connect to all sorts of things. So we can get into more of those as they need to,
Actually, yeah, for sure. Actually, you mentioned Spark SQL. We got a listener question here from Daniel Beach. What's up, Daniel? Yeah. What's the difference between Presto Trino versus storing, say, Parquet in S3 and using Spark SQL? Just curious on the tech differences and the pros and cons.
Yeah. So great question. When it comes down to Spark SQL is primarily an abstraction layer that's built on top of Spark. And so there are going to be it's primarily solving a very similar use case, right? So at the end of the day, I'm just going to say it's faster. Spark is primarily focused on trying to solve the kind of the old school way of handling big data. And I'm not saying Spark's old school. Spark is doing a lot to innovate and do what they do very well, which is, I'd say Spark's strong suit is ingestion, fault tolerance, making sure that your pipelines aren't breaking. But when it comes to reading, you're really there's not much optimization that goes into how Spark reads data out. It is a good tool. Spark SQL is a good tool if you're trying to kind of limit the amount of tooling you have. But I think this is kind of one of those traps that a lot of people end up falling into where they're like, oh yeah, I just want to have one tool that solves everything. And I think that when you grow to a certain level of scale and maturity in your organization, Spark SQL just does not ultimately scale up this for these ad hoc analysis queries that you would have with basically with Trino. Now, Spark does a really good job at, say, long-term transformations, ingestion. If you're trying to transform, let's say, data, let's say, merge into a similar data set, like a particular table, and you're trying to overwrite that data set. So Trino doesn't do a lot of the insertion pieces. Its primarily focuses on OLAP type queries, reading data out, really trying to think about the analytics, pulling data out aside. We do allow insertions, we do allow that kind of stuff, but it's pretty much an append only thing at this point. We're looking to grow out into that area as well. But today, if I were to just, talk about where Spark is good, where Trino is good, Spark is really good at ingestion. It's good at, inserting and kind of handling transactions to some degree. And then Trino is more about reading data out. And this is a common pattern that we see across many different organizations. One that comes off the top of my head was, Netflix, Zomato, all of these kind of organizations, they'll ingest with a Spark and I think, actually, I might have misspoke on one of those two I just said. One of those two uses Spark, the other one uses Flink. But anyways, so you have one of those type of tools to ingest, Spark or Flink to ingest data in. And then your ultimate goal with Trino, when you're looking at this, is reading data out. You could get by with Spark SQL for some time, but in the long run, it really comes down to, when you want to have this really quick turnaround and good kind of data just coming back to you in seconds, you're looking more at Trino versus the initial problem that we talked about with Hive, where you're talking minutes to hours. So.
That's interesting. Good question, Daniel. And the audience, feel free to ask questions as well. So you bring up an interesting use case here. I kind of want to get your opinion on this. There's a lot of companies doing data integrations right now. It seems like every day I wake up, there's a new data integration company. I mean, would Presto or would Trino complement those, or Trino compete against those? Do you have an opinion on that?
Yeah. So we're talking about like data ingestion pieces.
Mm-hmm.
Yeah. So we totally, in most cases, we complement. There are some cases though, like I don't want to totally rule out Trino for like for using any ETL job. So I think in terms of like, you have a lot of interactive jobs. That's like number one, you should be using Trino. That hands down. Like interactive jobs where you have a person on the other side of that query, like waiting for those results to come back, or in some sort of a BI tool, like that's Trino 100%. And then you have then on the other hand, for the kind of batch jobs, right? You're kind of like, I want to move data around, and it's probably going to scan all the data. It's not going to be filtering and this kind of thing. That's where you're going to be looking more into potentially like get into this gray area of like, which do I choose when? And so batch area, I want to move some data very like this, let's say on the smaller order, I would, let's talk terabytes, small terabytes, like, right? I'm not talking hundreds of terabytes right now. But let's just say, and Trino could handle this, but again, I'm trying to kind of come up with some vague delineation. There's always the what ifs and maybes. So this is going to be a very like pie in the sky number slinging right now. But let's just say low order number of terabytes. You want to copy that data over to some other data, and you're copying the data. You're not trying to constantly insert into the same table. Copying is very easy to do in Trino, and it's much faster. So if you're trying to kind of, let's say, get a quick copy of some data to play around with it in like a sandbox environment, and you just want to like quickly copy something from prod and move it over, that's like a Trino use case right there, 100%. You're not trying to insert, update, do all this kind of fancy merge stuff. You're just trying to like basically make a copy of the data. That Trino is great for that. And you're not also doing like these giant migration type thing. So migrations, I would say, you're still doing a copy. And so maybe that could still technically be done by Trino at some scale. But if you're using your Trino cluster mostly to help ad hoc, queries over your big data, you don't want to be slowing that down by doing these giant migrations on Trino either. So in that case, I would say that's a Spark SQL job, or that's a Spark job, or that's a Flink job, or that's a Kafka job. It's like you have other ways to do that kind of thing, to just move that data around. And that's where Trino is much more complementary. We're not trying to step on toes there. But yeah, I would say, in essence, ad hoc analytics, that's Trino 100%. So human in the loop, I would, is also another easy way to say that. And then you're talking more batch, like offline type stuff. That's a kind of what if. There are some times where if you have this job that runs daily, that copies data out, or you just want to really quickly get up and running and, play around with a little bit of data in a sandbox, that's Trino style batch ETL type stuff there.
Got it.
And that's a lot of generalizations too. There are times where, you could do other things that better in one set. It's always going to be a what if, depends. But I try not to give those answers too frequently, the depends, because everybody has to do that.
Daniel's got another question. Do you have to set up your own Jdbc or Odbc connections to connect to relational databases with Trino, or are there built-in connectors?
There are built-in connectors, and they're constantly growing. So, here's the experience. Let me just paint it out. It's like you have a Jdbc connector that talks to Trino. The queries that are sent in, this is not just like SQL, like a Hive SQL, right? And this is something I failed to mention in the beginning. So thanks for bringing this up, Daniel. But you are feeding in ANSI SQL queries. We're constantly looking against the ANSI SQL standards, and we are developing as tightly integrated as possible to those standards as possible. So it's not one of these. It's very similar to a Postgres, where you're like, we're making sure that we're meeting some standard versus just kind of coming up with our own words and syntax and things like that. So you can kind of have a lot more understanding of what to expect, especially you're not going to expect some word that came out of nowhere that, this came from a SQL spec and standard. So we every time the SQL spec comes out with a new thing, we have to buy those giant books that you have to literally those ancient textbooks. So that's the experience, right? Is that you're sending in ANSI SQL queries into your Jdbc driver that this talks to Trino. And then from there, that accesses everything. You now have a connector that you have. It's like a little config file that has and in the simple ones, I can link everybody to a really easy to find GitHub repository where you can just spin up a quick Docker thing on your own local setup, and it has usually 3 or 4 or 5 lines of configs, and then that's all you need. After that, Trino, that's that SPI I was talking about earlier, where there's code that's literally written to interface with Trino, the core Trino engine that talks to all these different tables. So this is where we really start to get into the power, right? You put in a little one little config file on your Trino workers, and boom, you have access to connect to all these different nodes in your system and all these different systems as well. So keep the questions coming. Let's hear some more.
Awesome. I got a question for you. So say I want to use Trino in my environment, what do I need to do?
Yeah, good
say
question.
I'm in AWS or GCP, pick a cloud, any cloud.
Yeah. So right now we are in process of developing a more standard Helm chart. Right now our Helm, I'm going to just be very honest with everybody here. We have a Helm chart that is kind of, in the works and still not totally up to par, but this is something that we know that is a big request from the community. So, today you would have to still basically download we have three options. We have Docker. So you'd have to kind of roll your own maybe Kubernetes setup with our Docker image, or you would maybe have some sort of custom install that pulls down. We have a tarball, and then the final one is an RPM if you do CentOS. So those are the three that we have out there, and so that's kind of something that we're in the process of making more scalable. But basic way, if you do some sort of if you're used to containerize, just deploying on Fargate or something like that, that would be something that you could use with just directly points to our Docker. There's just a lot of that comes on you to get that configured, and then soon I would say in the next couple months we're getting to a point of maturity with our Kubernetes options where hopefully we'll be able to get a much more solid experience for open source users that want to basically just deploy the Helm chart and it works. So that's where we're at today in terms of getting it set up on AWS. Locally, you can also, it's a very similar process. You're still setting it up, and the nice part about it, I would say, this is my experience. Before I was a developer advocate here, I was using Trino and setting it up in environments myself, using the tarball and stuff. And I have a lot of people that are kind of, giving the same feedback. Is the actual installation process is really straightforward. We have one artifact that you install as coordinator and worker, and there's a configuration that delineates between those two types of nodes. After that, they all, as long as you have everything talking to the same coordinator, they all know how to find each other at that point. So that's really, I think, the ease with installing Trino. If you're doing it out of the box on your own, it's really just setting up 3 or 4 configuration files, getting the artifact out there, and getting it set up. That said, we want to make that easier as well. We want this to be a one command Helm chart up kind of thing, and then just it's done. So
interesting.
Oh, and I should also talk about other options too. There's also enterprise options now that we're getting into some of Starburst. So Starburst, this is a company I work for. Just total disclaimer. We also have a lot of Kubernetes Helm charts that are much more mature than this, and has a lot of the auto scaling stuff that people want, and has a lot of other pieces. So you could also use Starburst. So we have a enterprise version that Starburst enterprise platform that ultimately uses Kubernetes to scale up. We also have a platform as a service, which is called Galaxy. So we can dive a little more into that. And there's actually some really exciting stuff coming in from the Galaxy side. Shall I just dive right in, or do we have any more questions?
If you have questions, the audience, definitely ask them. Otherwise, let's get going on the
Galaxy.
what's happening in Starburst. Yeah.
Yeah, sure. So yeah, we'll veer off and talk about some enterprise features here really fast, especially if you're like trying to get up and running. This is currently, I would say, in any cloud environment, the way to go. And so yeah, going into Starburst, we have a couple free trials on Marketplace, which will give you those quickly spin up on Kubernetes. So you go to AWS Marketplace or GCP, Google, or any of the Azure. Go to their marketplaces and just type in Starburst, and you can get up and running on a trial there. And what that's going to do is it's going to spin a lot of those things up automatically. And then now back in February, we launched our product called Galaxy. This is basically a platform as a service that now it kind of takes away if you're like a smaller company or kind of mid-level company, and you don't want to have your engineers super taxed out on doing a lot of this installation stuff and maintenance mode and figuring out all these little parts. You just want them to basically configure the connector and point it to the right spot, and then start running your queries. And the other part would be kind of how do I integrate this with other things? That's your new job as a manager. Whenever you get Starburst, you're primarily focused, instead of installing and getting all the bits running there, you're just focused on, let's set up another connector that points to my data lake. Let's set up another connector that points to our MySQL, our operational databases. And now we can run queries across those. And you don't have to think about a lot of that installation piece or managing Kubernetes clusters, all that piece. So that's kind of the two things we have coming. And I am not, I want to put this out as a teaser. I am not at liberty today to talk about some of these new features that we are going to be introducing to the Galaxy product. But those details will be coming out in later this month at a Trino Summit. So that is going to be coming up on the 21st and 22nd. Joe, can I give you a couple links to basically shoot out to people and add on to this afterwards, or,
sure.
Or do we have to do it live on the show? Yeah, I'll give you a couple links after this so people can go find this. But basically, Trino Summit is going to be a 2-day virtual event. We were going to do hybrid and then Delta, all that stuff. So Trino Summit is going to be basically all around open source. But the first, with the exception of the first keynote, is going to be opening with Starburst, and we're going to be talking a little more details about some of these changes that we have coming in down the pipeline for our Galaxy setup. We've learned a lot of things. It's one thing to deploy Trino in an on-prem or in a kind of mimicking an on-prem in cloud. But there's a lot of cool things that you could do to optimize that, and it's different in every single cloud provider. Yeah, I'm sure you've had plenty of enterprises talk about the changes that will go across different vendors depending on what they offer, right? So cloud vendors, I mean. And so, when you have these kind of learning lessons and how do we optimize this? How do we make this piece faster? You start to kind of bring in a lot of cool options for features and getting things up and running super fast. So I don't want to dispel too much, but we'll talk. The keynote there on Trino Summit is going to be a big reveal day. We're also going to be talking even more about it at AWS reInvent if you're heading to that. So I'll send those links to Joe. Definitely check out Trino Summit if you're kind of curious about Trino in general. We're going to have DoorDash, Netflix, and a whole bunch of other people, LinkedIn, all speaking there, kind of talking about their setups and different cool things that they've built on top of Trino as well to make it even faster. So
make it even faster. That's awesome. Yeah. Do you guys? One question I have: Do you work in a kind of a multi-hybrid cloud environment?
Yes. So that's another great question. Hey, you're pulling out all the stops, the things that I'm forgetting.
But this is not scripted, by the way. So
yeah, yeah, it's really not. It's actually convenient that you're thinking about all this. Yeah. So another thing product that we released shortly after, I don't know, shortly after, it was sometime. Time is very irrelevant right now in my head. But we have Starburst Stargate, and this is a piece that allows us to, so you take into account like Trino and Starburst is ultimately, it's ultimately a query engine that, doesn't have to be tied to any particular storage at this point, right? So it's kind of got these interesting properties where if I want to, I could technically just like have an engine running somewhere, it doesn't matter where, somewhere. And now I should be able to point to things not only across my cloud provider, but now I can actually point across other clouds, right? So I can, I don't have to even necessarily have another Trino or Starburst engine sitting. And actually in this case, it's specifically Starburst because this is not an open source thing. So I specifically don't have to have another Starburst engine sitting on across different clouds. I could actually just have the one installed, let's say in Google Cloud, and I want to talk to something in AWS. I want to talk to something in Google. I want to talk to something in Azure or Red Hat. Like now you have all these opportunities. As long as there's like something addressable that it can hit, you can now go cross cloud. And the cool thing that we're thinking about on a Starburst, like the first thing that everybody thinks about when they think like multi-cloud and cross cloud, they're like, holy crap, I have a whole bunch of egress charges I'm going to be,
I was about to ask you about that.
So that's the first thing that comes to my mind too. Like actually when this was brought up in the meeting, I don't know, like months ago, I was like, well, why would anybody want to do that? Because nobody's going to want to pay those egress charges. So there's a lot that Starburst specifically has been thinking about in this area of like, how do we start to cache these kind of segments of the query? So a lot of times, as I was kind of mentioning before, like Trino and Starburst are really thought about human in the loop type queries. So you have like Trino and Starburst being pulled in for like, primarily, let's say BI tools. Let's say think of Tableau sitting on top, and BI tools, you're usually like kind of changing like one or two things on the UI and then rerunning practically the same query. So right. A lot of times when we look at the kind of signals, once you run a first query, that is a really good indicator of what's going to get run the second time and the time after and the time after. So when you're looking in those particular use cases, now this isn't everything that we use for Trino, as we talked about before, but for those particular use cases that maybe depending on how you use it will be, let's say 60 to 70% of your traffic, that stuff can get, cached and can basically, you avoid those egress charges at that point. So there's a lot of ways that we're looking at where on the whole line do we cache it? How do we, even just trying to cache it in the same cloud, where you're trying to avoid, putting more processing time on your data sources. You would rather just have the results come back as quickly as possible. That's also something that has existed for a long time. But then, you can utilize those, but also like, how do we do that at the same level, going in-house to a setup coming from, let's say, GCP coming from AWS. So that's definitely something that we're looking into, caching. A lot of how do we expose that configuration to clients that are, trying to get that set up just the way they like it. Do they want to cache everything? What's the, and there's still a bit of I'm not going to say what exists in there right now because it changes a lot and there's still conversations about what will be there. So that stuff will be more discussed as time goes on.
Interesting. Switching gears a bit, Starburst, sure. They're calling themselves a data mesh company, enabling the data mesh. Walk me through that. First, what is the data mesh? I think there's some definitions and a lot of opinions. And then how does Starburst and Trino tie into the data mesh?
Yeah, so I would say here, and I'm going to do a quick Google sesh. I'm going to do principles because I always forget the principles if I have to pull them from my head. Principles. I am not the core person to ask about data mesh principles. Here we go. The 4 principles of data. Oh no, that is not the one I wanted. Here, give me a second. Hey,
Zamak, if you're watching, feel free to jump on.
Yeah, just let us know. So yeah, actually a good point there. To at least bring out, this was created by Zamak, and I will never say her last name, Digastani. Is that like even close? Hopefully. So Zamak is the author of this concept called data mesh. And so I have the 4 principles in front of me, but I will grossly simplify what data mesh is to me if I'm trying to think about it in my simple, dumb mind. And that is, there's these 4 principles that she did super well to summarize in her more recent iteration of talking about data mesh. And this is on the on one of her fellow ThoughtWork colleagues' websites, Martin Fowler, and I'm sure you all know Martin Fowler, but just go to Martin Fowler and or like martinfowler.com and search data mesh, and you'll find data mesh principles. And it comes down to these 4 principles of domain-oriented decentralized data ownership and architecture, data as a product, self-serve data infrastructure as a platform, and federated computational governance. So that's a huge mouthful, even to just like, especially to say across like the line here and people like hearing it in there, like what this is. So I'll try to like talk about where I think Trino and Starburst fit into this narrative and where we don't. And kind of, I think that'll help kind of talk about what these actually mean. So domain-oriented decentralized data ownership and architecture. So this is ultimately like, talking about, if you heard of the domain, there's a popular book now that I just blanked out of my head, but there's
domain-driven design.
Domain-driven design, that's the one.
Yeah.
So you think about like, this derives from that type of domains. That's what we're talking about here. How do we design services to encompass all things about a particular domain? So if you're in a, let's say Amazon, how do I have the domain of shopping cart? How do we handle like all things shopping cart, how things get added to the shopping cart, how, I'm sure Amazon does like breaks it down even further, but let's just say you have these kind of different domains within your thing. And then there's another domain in Amazon where it's like shopping, the shopping experience, or there's another one that's talking about, videos and streaming and stuff like that. So you have all these different domains that sit underneath your org, and you ultimately want those services, or basically you want those services to be clustered by teams and people that are like working on those services, and then they own a lot of the infrastructure and manage how that gets deployed out. And we've done that at scale now very well with Kubernetes. And so when you look at service mesh architectures, you have all these kind of clusters of services. Those are usually clustered by a domain. And so what data mesh is trying to do is trying to kind of piggyback a little bit off of that service mesh kind of concept and apply that to data now. Because what we've traditionally done is we've said, okay, let's centralize everything on data into a data platform team or a data engineering team. And what Zhamak is trying to push for is, what if we just decentralize that? There's a lot of implications that come from this, and so we have to talk through those. But it's and some are negative, but there are also a lot of positives that come from that. So now I think about it as like you instead of having these data engineers that are these just doing data and they don't do anything else. Now these data engineers get dispersed into different teams that are domain oriented. Okay, we talked about that, domain oriented and decentralized into these different teams. So now the shopping cart team now has a data engineer that works with them that is owning their data model. Essentially, how do we model all of the data that's sitting in this domain, and more importantly, how does that model that I'm creating mesh with all of my other data engineering buddies on the other domains, and how does that fit in the bigger picture of our organization? So this is where that domain-oriented decentralized data ownership and architecture comes into play. And where Trino fits in here is that now if I'm this data engineer that's on this one domain team, and I have a perfect solution to how we're going to solve things on our team, on our domain. Maybe I'm going to use a little bit of MySQL because we have some operational data. Maybe we have a little bit of data that is ultimately being pushed into Elasticsearch for searching capabilities on the front end, and we have all this data just kind of sitting there. And we ultimately figure out, okay, we have all this data. How are we going to expose this to the world, essentially? So this is where we start figuring out, Trino could be a very good key player in this part, because we ultimately allow for this architecture to take place. All these domains can now have their own kind of distributed architecture, however they see fit, whether they use MySQL, whether they use Mongo, whether they use Elasticsearch, a data lake of sorts, and BigQuery, whatever they want to use. And Trino can talk to all of those. So this is getting back to that federated query use cases. And that's where I really see Trino fitting that one particular principle. The next one is data as a product. And so this is talking about, how do we if I have something exposed, how do I make sure everybody else knows about that? And how do I make sure that, like, if I'm some analyst on the team that's trying to understand how these two domains fit together, let's say, how does shopping cart and shopping data mesh together? How do I go and discover that? And this is where Trino is like not as involved. I would say this is something that's more of an Amundsen kind of thing, or, you know, and so Amundsen is a data discovery project that also has a enterprise piece called Stemma. We did a Trino community broadcast on this and showed these two together. But what they basically do is they try to like suck out all the metadata about all these different systems, and then try to basically make a nice little search engine for you to find this data and to find the, you know, what's the schema around that, and how does this, you know, field relate to the field from this other team's domain. So this is where Trino is like, Trino enables you to have those pieces exposed, those metadata pieces exposed. You could also use, you know, technically use a lot of our information schema pieces there, but it's not the only piece that is needed to actually get this data as a product piece working. So that's where I would say we need a lot of help to actually fit that billet. Then there's this self-serve data infrastructure as a platform. So how do I actually enable all these data engineers to fall under the same, like to fall under an infrastructure platform that everybody can access, but ultimately gets exposed? Yeah, essentially, I expose myself to some sort of type of standard that's used across the company. And once I expose myself to this standard, something's able to find that, you know, that data source now and get access from one single location. And you know, if I'm a data scientist and I need to go find this, I'm able to actually run these queries. And this is where it really helps, you know, the people, the data analysts and the data scientists consume this data. This is 100% Trino, right? This is like, I'm now able to kind of give you this one single point of access and allow you to be able to suck all the data into that one point and query it, you know, change up the SQL query however you see fit, and it comes to this one location. And that's ultimately up to the, you know, as long as the data engineer is following the standards that we have set as a company, we now expose that data, you know, however it's required to be exposed, and Trino is now able to find that and pull that into that infrastructure. And then the last one is another one that Trino doesn't help with. So we help with two, kind of are involved with one of them. And then like this one is 100% not us, federated computational governance. And this is the one that I think is like needs the most research and needs the most product innovation around. And this is like, you know, how do I kind of automate that, you know, all that stuff I was talking about coming with the company standard, and how do we, you know, police this, and how do we do that? You know, a lot of that is still done by humans at this point. And there are a lot of interesting ways in which we can kind of start to figure out where do we need to de-stress the human cognitive load and try to kind of piece in more automated pieces that make the decisions and make the you know, how things happen much more automated. So something that comes into my mind is like, you know, you have something similar to like a Kubernetes YAML file, a set of, you know, YAML files somewhere similar to like Kubernetes. And these ultimately indicate your processes. So like, you know, how long does data sit around before it gets deleted? And what are my different GDPR processes that need to be pushed into place? All that can be maybe somehow expressed in a YAML format or something like that. And that can get, you know, some other system that doesn't exist yet can take action upon those configurations and apply that across the org. And what's interesting is that, you know, once you get to this level of federated computational governance, if you have like a change in how your company has to work, you don't have to like go walk around to all these different domains, you know, and be like, hey, this is how we do this now. Hey, this is how we do this now. And then like, you know, 3 years later, once, you know, the process has changed twice already, you don't have to actually get all these people on the same page. You're all on the same page as soon as you flip the bit or the switch or the configuration in that you know, centralized piece. So that's where, so Trino fits into a lot of those, and Starburst as well. You know, so Starburst, we're really doing a lot more research and thinking about how do we fit in this narrative of data mesh, because we think that our technology actually does fit a lot of those pieces to enable that infrastructure and to enable that platform. But we don't have all the pieces, and we're always interested to kind of figure out how does that how do all these things fit together? And so this is where, there's open research, there's a lot of open questions, and I'm really just intrigued by this decentralized architecture that we've applied to the service layer. I'm really interested to see what happens in the next 5 or 10 years, and we start seeing that to kind of trickle down into the data layer as well.
Yeah, I'm fascinated as well. I talk to a lot of companies that do like observability and quality and governance and everything else, and it seems like this, on the surface, data mesh, inverts at least the domain responsibilities, but with new responsibilities comes new challenges.
Yep.
So governance being a key one.
Yeah. That's a huge one, right? It's like, if I don't have a single data team to solve this, to come to a consensus about how things work in the data world, how does that work, and how do we fit into a platform? And the answer is you shouldn't, but like, how do we as humans like spread across our intentions and how we're going to run this data platform and do it in a distributed way,
I think it really comes back to, there's the old Conway's law, right? So organizations will design systems that reflect how they communicate. Yeah. And I think that in order for something like data mesh to work, and it really does come down to making sure that your organization, like most problems in companies, it's organizational at the end of the day. Technology is here to either assist in current organizational setups, or it will amplify things that are working well and things that are not working well. So it's interesting, but I was always wondering like where Starburst kind of saw itself fitting into that mix. So this provides a good amount of clarity for myself personally, because it's just a question I've had. It's interesting.
Yeah, cool. Yeah. I mean, it's definitely something like it's a growing and constantly discussed article or concept. And as it grows and as it progresses too, like a lot of things where we were initially thinking about it, we've changed our thoughts on that as well. So and I think right now data mesh is as a big buzzword, and we're figuring out what it actually means, because these things are kind of the same way that big data was just like, oh my god, what is this? It's just databases, right? But like you start to figure out what it really means over like maybe 5 years. Then at 10 years you start to realize that you get inundated with the legacy software at that point that is was the initial attempts to solve it. So hopefully we don't fall into that. Hopefully we keep progressing, but we want to be that kind of on that initial wave of understanding what this is and how we can help customers that do want to see themselves in this distributed data type of platform. How do we help them posit themselves in this kind of new era, and and figure out what does data mesh actually mean? What do these principles actually mean? And how do we actually realize something like this without, just totally, screwing up what we had before, where it was a nice centralized bit of discussion that we had on one team that, they set the rules and standards for how everything went. And therefore they're running around with their head, like chickens with their heads cut off, trying to figure out how to get everybody to agree on everything. It's already a problem, but maybe this is an interesting way to go around solving it. So.
I think depending on your data maturity and the size of your company, it would make a lot of sense. And in the article, it does point out too that this is appropriate for companies that are at a certain scale, probably both maturity and obviously size. This wouldn't really work if you're a small startup. I don't think, just because if you can't talk to each other as a small team, a large team isn't going to help you at that point.
Yeah, this is definitely an enterprise platform problem. I would say, and I'd say that the one cool thing is like, I'm going to go again, like selling my Trino pitch, but Trino can kind of fit into a lot of different ways, right? If you are in an early phase and you just don't know what your architecture is and you constantly need to change that, Trino is a nice barrier that sits on top of a data of your data team that can shield them from a lot of the changes that they need to make in an early phase. And then as you progress into more of a mature phase where you're like, okay, we know kind of what we want now, but we're not big enough to, let's say, do something like data mesh, then you start going into something like a data lake, or you start just kind of putting historical data into one object store, and that's data lake, right? And that's where Trino fits really well on that side as well. We're shielding you from a lot of the changes you're making. We're letting you giving you the freedom to change up your design, and then but you're ultimately, everybody just interacts from that same single point of access. And then as you start going further, you might say, hey, we need to start distributing our platform now, because we're growing to this level of maturity that just we can't scale on one team. So let's start moving into data mesh and start seeing something like that. So there, definitely to your point, like that's definitely where we don't want people to think data mesh is for absolutely everybody. It is 100%, and it's also to be also very clear, it's an analytics thing. It's not a operational database setup. This is for your your data scientists, your machine learning folks that are pulling this data out, or business intelligence folk. This is not to tie your operational data in with your analytics data. That is one thing that Zhamak makes very clear. Don't do a transactional, like start pulling versioned data from your operational data in MySQL and start pulling that into this whole data mesh piece. It's supposed to be the OLAP side of the house, essentially. So.
Yeah, I think as Bob Gran says here, as all organizational tech deployments, it will only be successful if it fits with how the organization actually functions today. The evolutionary changes. Yeah, I totally agree with that.
Totally.
We only got a few minutes left, but Robert has a quick question here. It sounds like you're talking about workload management, or is he misinterpreting that?
Yeah, it's really talking about. So we're talking that's in relation to data mesh. It looks a lot at the this level of this level of how are humans talking to each other, really? It's just as much of a social type of how do people interact on teams, and how do things work, to also talking about like how do we deploy an architecture. So the pieces that I was talking about before, where we're talking about the federated computational governance, this piece is kind of more aimed at like there are some things that computation or services or I guess computers can essentially solve, that take a lot of this strain or these conversations off the human, so that you're not having to wait 5 weeks for somebody who went on vacation and they're the only person that can approve something for data to move through. Like that's what a lot of this is trying to avoid. Is that because like when you have that centralized bottleneck issues happening there, you're ultimately you're going to delay a lot of things from happening in your organization. That's ultimately going to delay your agility and your ability to move forward as an organization. So this does really also hit in, though, outside of that computational level. You should be using data mesh as a mechanism to question how are we using things, how is our teams aligned, how do we make it, forces those conversations. How do these data sets actually combine together? So those conversations happening is also a big part of data mesh. It's not just make everything a computer land and that solves it, no more meetings. And it's definitely, in fact, maybe at the initial ramp up, it's going to be a lot more meetings. So that's.
Well, you should work on a tool that ends all meetings. I think that's a good goal. So Trino, I'm going to put a pull request in for ending all meetings.
Yes.
If you could just.
We're also going to try to solve world hunger and figure out the rest of that as well. So that's
all being announced at the Trino conference. When is the Trino conference, by the way?
Yeah, Trino Summit. Come check it out. It's October 21st and 22nd, and we'll be. I can't remember the times now, but I will be sending Joe the information, and I will be there. I promise.
Awesome. Hey, Brian, I think it's time to wrap it up. It's been a lot of fun. Thanks for debuting on the Joe and Friends show. It's a lot of fun talking to you. For people who want to learn more about you and Trino and Starburst, how would they do that?
Yeah, so as you see my little thing down here, Bits on Data Dev is where I'm at on the Twitter space. If you want to learn about Trino, it's at TrinoDB. And then if you want to also go to the website, it's trino.io. I think that's pretty much it. Just check those out. There's a community page. We have a Slack channel where we've grown just over 5,000 now, and
Nice.
a lot of cool things discussed there. We have a dev channel where if you're wanting to contribute to Trino, we can help you out there. I really like to welcome in a lot of we call them Trinoobies. And then if you are, if you were just wanting to be also on the user side, ask anything in general, ask anything in troubleshooting. And we try to be as responsive as possible. That's the best way to get a hold of us.
Awesome. Ryan, it's been a lot of fun. Thanks for showing up, and we'll have to talk again sometime soon.
Sure.
So next week on the Joe and Friend show, we got John Wills from Relation. Going to be talking about all the fun things about data governance.
Nice.
So if data governance is your jam, come check it out. John's actually a really insightful person. I talked to him before, and I felt like I was in the presence of greatness. So this will be a really fun chat. Same time, Wednesday, 10 a.m. next week. So we'll see you there. Also, if you aren't subscribed to our YouTube channel, please do it. Just look for Ternary Data on the YouTubes and hit the subscribe, as well as subscribe to our newsletter at ternarydata.com. Got a lot of exclusive content on there that you won't find online. So check it out. Hit the subscribe button. Ryan, thanks. It's been a lot of fun. So,
thanks for having me. This is a great first episode. Thank you.
Yeah, great. Thanks to the audience as well. Great questions. And we'll see you next time. Bye-bye.